This problem says find the sum of the geometric sequence. So we're going to look for a sum here, and we're adding these up, and that's where this is coming in at. So now keep in mind my formula says for a sub n, my a sub n is going to equal 3 over 9, because that's my first term, that's my a1, and my ratio here is actually 3 to the n minus 1. And I think that would work here, so we're going to try that out and see. So my a1 is going to equal 3 over 9, and I see that this is really going to be 3 to the 0, and 3 to the 0 is 1, so I get 3/9. So we see that this is going to work out for us. All right, so that's going to be our a sub n term. So the reason why we want to find out our a sub n term is so that we can now set up the series. Now we want to set up the series for this because guess what? There's a formula for this. So the series then is going to be n equals 1 to 15. Okay, and it's going to be 3/9 times 3 to the n minus 1. And that formula is, so now looking at this formula here, it says let a sub n be a geometric sequence with first term a1 and a common ratio r, where r is not equal to 0 or 1. The sum s of n of the first n terms of a sub n is down here, and we also have down here that's partial sum there is going to be a1 times 1 over r to the n over 1 minus r. And see, here's that series that we actually set up previously here. So now that means we're just going to kind of plug in the information we need to plug in for this sum. All right, so if we look at the problem we have here, we can see that our r is 3. So that's here and here. Okay. We can also see that our a1 is 3/9. And I think that's about all we need for this. Now again, it has to be in this form to begin with here, and we have that, and our n is 15. So let's just plug that all in now. Okay, so now that we have this sum, okay, you had to move it down. This is going to equal my a1 is 3/9. Now again, if that's bothering you that I didn't reduce that, definitely reduce it. It's fine. On the top, I'm going to have 1 minus. My r is 3, so I'm going to put a 3 there, and my n is 15. And then this is just going to be 1 minus 3 on the bottom. And this is just times here. So what we're going to do then is we're going to clean this up some. That 3 to the 15 is quite a bit. So this equals 3/9. And then on the top, I'm going to get 1 minus, and that number is 1, 4, 3, 4, 8, 9, 0, 7 over, and I'm going to put just -2 down there. So that's the number I have. And I'm just going to simplify this now and get it down to simplest terms. And definitely we can use our calculator for this. Not a big deal. So this is what we get for our answer. So it's going to be 7,174,453 over 3. And that's in simplest form. So there's our answer for this one. That's the sum of the sequence. Okay, now we're going to do the other one. Now this one is already in the form that we need it to be in to make this a simpler computation. Now when I think of this, this is going to equal, and then my a1, that's this number here, that's going to be 4 times, and then on the top I'm going to get a 1 minus, and my r is 3 here. So that's 3 to the 15th, again, over 1 minus 3. That's interesting. that gives me close to the same number, but instead of a 1/3, I'm multiplying it by 4. So it doesn't change too much. And again, I'm just using this formula. Not a big deal. Looks complicated. And right away, what I'll notice is this 4 and that 2 down there, because 1 minus 3 is going to be a -2. That's going to simplify. So this isn't going to be a fraction at all here. So this is actually going to equal 28697,812. Now again, I just did this one on my calculator for the computation. So there's my answer for this one. That's it.